Hello and welcome everyone. Just a quick note before we start. Welcome to the presentation Telehealth on Fire. The session is pre-recorded. However, obviously the Q&A session after the video is going to be live. Enjoy the video.
Welcome to FHIR Dev Day Telehealth on Fire. My name is Audrey Egan, and I'm a solutions engineer at Google Cloud focused on healthcare and life sciences. And I'm with my colleague, Anupya Nalamalapu, also a solutions engineer at Google Cloud focusing on healthcare and life sciences. Why Telehealth on Fire is important. COVID-19 has created an urgency for virtual appointment capabilities optimized for healthcare workflows, but also centered on patients' continued accessibility to care. Telehealth services now in 2020 have an impact not only on access to care for people who have been living in more remote locations, but also for people who would forego care. But it's also for the entire population of people needing to manage their well-being during this pandemic. Telehealth on Fire has really created an avenue for expanding access to essential health services while still providing a secure patient and doctor exchange. Particularly the FHIR specification and extension of a secondary FHIR store create opportunities for integrating new patient services securely with existing EMR-like technologies. Our primary objective was to create a telehealth waiting room experience that allows a patient and physician to join a virtual appointment. We were also looking to direct the patient from their usual portal login to an appointment lobby and then to the virtual appointment itself. And doing this by securely integrating a meeting session URL into a FHIR resource for both patient and physician to then access. We also wanted to create the meeting session URL when the doctor arrives so that no persistent or lingering meeting session links were floating around or able to be accessed. We also wanted to use the waiting room functionality to incorporate chatbot services, which would help check in the patient, check for symptoms, see if allergies are still up to date, and other types of pre-screening questions that happen before appointments. A non-goal for us was integrating with any kind of specific scheduling product. And in this case, we're working with OpenEMR and the Google Cloud Healthcare API as the FHIR store. Now I'll turn it over to my colleague, Anupya.
Thank you, Audrey. In this solution, there are three major app components: the EMR application with a primary SQL store and secondary FHIR store using the healthcare API, as Audrey mentioned, the conversational agent backed by the same healthcare API FHIR store, and a third simple waiting room React application with, as you can probably guess, a healthcare API FHIR store backend. This FHIR store is a consistent data store in the cloud that allows for information portability and standardized data exchange. Going back to the story that these apps were built for, there's a list of prescribed actions as shown here to demonstrate this flow. We'll give you a quick demo of this story soon, but before that, let's quickly dive into the software architecture of the application. Before I go through this, I want to explain the key a little bit. The green indicates action elements, the blue indicates EMR app touchpoints, and the red indicates waiting room app touchpoints. The purple are the connecting pieces between the EMR and the waiting room application, so the FHIR store. Hopefully it'll make more sense as I walk through it. So Jonah, our patient, will first log into the application. They'll see the UI and opt to schedule a televisit. Here, Jonah can click Schedule New Appointment. Click Virtual Visit. Let's say this will create an appointment in the FHIR store in the appointment object and create an encounter object to reference the appointment object. It will initialize the object status to planned. And after the appointment shows up in the patient's UI, obviously it's the day of, so it showed up today. And in a real life situation, that wouldn't be the case, but for the demo, let's assume. And now it's time for their appointment. They will have the option of clicking the Start Appointment button. After they click that button, it'll update the status in the FHIR store to arrived and redirect this patient to the waiting room application that you see here. The patient ID will be passed to the waiting room application in this process, so the waiting room is able to access the relative FHIR data, as you can see here. Now the patient is in the waiting room and will interact with the Dialogflow intake chatbot, which is able to access the FHIR as well. I won't go through it right now as we don't have too much time. Once it's done interacting with the waiting room, they'll click the Notify Provider button. This will also alert the provider that their patient is ready for the appointment, and in the meantime, the waiting room will start checking the Cloud Function logs to see if the meeting link has been populated in the FHIR. Now we switch over to the provider, and they will be able to log in and see the Start Appointment button. This button will kick off the Meet function to generate the Meet link utilizing the Calendar API. In this case, we use Google Meet, but this part of the code can easily be replaced with any other web conferencing tool. Here, the code will authenticate the client, create a calendar event to generate the Meet link, store it in the encounter object, and then delete the calendar event as to not clutter the provider's calendar. It will also update the status of the encounter to in progress. Now the provider is able to go to the virtual meeting and join. It's important to mention that as well that when the Meet link gets stored in the FHIR, a pub-sub topic will be triggered and kick off the Cloud Function. Now the waiting room application that the patient is in will receive a notification that the Meet link is available. This will give the patient the option to join the Meet and redirect to the Meet. The patient will ask to join, and the provider will let them in. Then after the televisit is over, the provider will be able to mark the appointment as complete and mark the object status as finished, and that ends the interaction with the healthcare API. With this implementation, there were a couple specific issues that came up that we didn't anticipate having to solve for. The data interoperability and virtual Meet configurations were the easiest to set up. We utilized OpenEMR and open source EMR for this demonstration, and it is currently deployed on Kubernetes. There are 3 workloads: MySQL, the OpenEMR app, and the phpMyAdmin. I won't get into the GKE deployment specifics, but there was already a SQL in place, and replacing it with a FHIR didn't seem like an efficient idea. And we also felt like the use case of a primary FHIR and a secondary FHIR in the cloud is a common use case in today's climate. We implemented the Healthcare API FHIR in conjunction with the current SQL store, which also means that as the use case arises, you would need to store certain object IDs from the SQL store to relate the object in the FHIR back to the SQL store. We decided to store the Meet link and the encounter object in the secondary cloud store as it needed to be portable between applications. The second major complication was the Dialogflow integration. This is when the primary versus secondary FHIR really became important. The chatbot would only be able to access the secondary FHIR, and this places limitations on the data we could use for the conversation. So for this demo, we stuck to allowing for a conversation about the appointment itself and lightweight symptoms that could be inputted into the description of the object. Any other information couldn't be accessed. This is definitely something we would like to put some more time into solving. Another complication was to make sure that the data that was outputted into the chatbot questions didn't contain any PII and stayed HIPAA compliant. All of these products are HIPAA compliant, with the caveat that the application development is also compliant. Finally, the other interesting problem we faced was how to make sure that only the patient had access to their information and to the right video conference link. If there were several video conferencing links being processed in the system simultaneously, this is something that needed to be accounted for. For the purposes of this demo, we passed the patient ID in an encoded hash via cookies and URL parameters, but obviously this is not a safe way to implement this. In a real implementation, we would recommend enforcing an OTP to log into the waiting room and verify patient identity. Then if a patient would want a companion to join the appointment with them, then the companion would be able to securely access the waiting room or the Meet directly, only if the patient had sent it to them and sent them the OTP verification code, or if they had whitelisted them as another attendee on the appointment, which we don't have in this implementation. One benefit to the Healthcare API implementation was that we could set up a stream to BigQuery as updates to the store were made. Up until this point, like up until we set this up, we had manually checked the FHIR store via CLI to test the code. The BQ stream helped speed this development up tremendously. Obviously, there are several critical moments to the solution that we scoped in the development of this and improvements that need to be made in legitimate implementations, but the implementation of the healthcare API as a secondary FHIR store, being able to provide for easy data interoperability, and implementing chatbots with access to this data were great solutions to realize in this demo. It opens the door to several other solutions in the new age, with the FHIR store as the backbone, like a hub with spokes of concepts like telehealth, chatbots, and waiting rooms. So now I'll pass it off to Audrey to conclude the presentation.
Thanks, Anupya. Thank you for listening to our Telehealth on FHIR presentation. You can find us on the Whova app speakers gallery, as well as through email and on our LinkedIns.
All right, thank you very much for your presentation. Now we can go to the question and answer session. People need some time to come up with some questions. So until we are there are 2 points in the presentations that you might, or that you previously said you might want to elaborate on a bit. I'm just going there. What's the virtual room? So please take it away.
Thank you so much, Walter, for kicking it off. There are a couple things that we didn't go into too much detail on, such as the software architecture, which was right before this, the HIPAA compliance and how that was set up, or the BigQuery stream, for example, how that was set up, etc. But there's also the session, if anyone is interested, that some of our colleagues are hosting later today. I think it's in an hour or two on the Google Cloud Healthcare APIs. And so if that's interesting, please feel free to attend. And other than that, we can do our best to field any of the questions related to that or elaborate on any other parts of the presentation.
Actually, there's already one question. I will just read it out loud. You mentioned the data being streamed to BigQuery. What are you doing to make FHIR work in BigQuery?
Right, so I can take that. The BigQuery stream is simply, it's really compatible with the healthcare API in specific. All you do is run a command line that connects the BigQuery project data set that you have set up to the FHIR store. And as long as you have the data set ID of the FHIR store and the data set ID of the BigQuery set up, that's all you need. And it's really fast.
Yeah, and BigQuery has built-in FHIR schema capabilities. So it becomes very easy to kind of make that ingestion. And then from that point on, once you're kind of streaming the data, just general like analytics rules apply. And you can go ahead and use the BigQuery console or other tools to write some kind of SQL command to access any form of like nested fields within the FHIR schema, but it does a rather excellent job at kind of flattening that out and making them more accessible based on your queries.
All right, clear answer. Thank you very much. Do you maybe want to expand a bit on this graph? It's a very dense graph, maybe a bit more detail.
Yeah, we kind of went over this really briefly. We didn't give a lot of time to focus on it, but so basically, like I said in the presentation, the green elements, I guess it's hard to read, but the green elements are the action items so that's where you would start to read the graph. You would go from the patient creating the appointment to the patient starting the appointment and then entering the waiting room. And then the provider would start the appointment to create the meet link, and then the patient would hence join the meet link after that because it's not generated up until that point for safety reasons. And then the provider basically would wrap it up, like mark the appointment as complete. And then those are all the touch points of the users. Then all of the other pieces are related to the actual technical implementation, obviously. The purple box above with the gold, I guess, update status and different functions are connected to the healthcare API specifically. So the update status would be, you would update it 4 different times. You would update it to planned, arrived when the patient enters the waiting room, in progress when the meet link is created, and then finished when the appointment is complete. And we have so many touch points to be able to update that. And then at that same time, you start streaming to BigQuery automatically. Every time something in the FHIR store is updated, the BigQuery stream will also get updated, and that was very, very convenient for development purposes, and also to present how the FHIR store was interacting. That was also very useful. And some other functions we implemented were we'd save the appointment data when the appointment was created. It's important to mention here some things that were not in scope is we did not develop a scheduler. This was an existing scheduler that was already in place. And that is a completely different solution that would need a lot of different time in the telehealth space. So we didn't address that. And then we would start the meet link, add the observation, and then you get the meet link. And then on the blue, all the blue components are the meet touch points and the EMR touch points. And we use the calendar API to generate the Google Meet. And then the red touch points are the patient touch points, so the waiting room and how that interacted with the FHIR store. I think that covers all of it. Oh, it's also important to mention we're using PubSub to trigger the cloud function. And that's how the connection really happens when the waiting room, because they're 2 separate applications. The EMR is one application and the waiting room is one application. And so for them to be connected, we needed to have that PubSub trigger.
All right, great. Thank you very much. You also mentioned that we should expand a bit more on the virtual waiting room. What can you or what would you like to add?
Yeah, so on this part here, so the different statuses you can see, so the different statuses that we would stream to BigQuery, those would be changed via this UI. So as soon as the patient, joins the meeting, that's one status. So we can kind of keep a log of events based on, maybe they, showed up to the waiting room and then left or something like that. We were able to capture that. And then Anupya, do you want to go into the PubSub, explain a little bit about how PubSub gets the meet link?
Mm-hmm. So when the provider on the EMR side generates the meet link, when they click start appointment, it kicks off the PubSub trigger, and then it'll store the meet link in 2 places, the cloud function logs, and then the EMR FHIR store, the secondary FHIR store as well. And so when the meet link is in the cloud function logs, or there's that flag saying the meet link is ready for them, the waiting room would then check the FHIR store to get the meet link, and then it would be returned on this end. Mm-hmm. And we didn't go into the dialog flow implementation as well. At this point, the dialog flow implementation was a little tricky because, as we mentioned, the PII and HIPAA compliance was difficult to work around because we can't present any of that in the queries that the chatbot might present. But if anyone has any questions on the dialog flow implementation, we can definitely elaborate.
Yeah, we did have different forms of the chatbot implementations as well. So like this, obviously, at this point in the patient appointment, the chatbot would be asking about, previous symptoms that were, noted during appointment scheduling or any kind of notes like reason for appointment. And that's what the virtual kind of PA chatbot would be checking for there. So this is kind of like a, room intake type of a bot that would prepare them for the doctor. And there's, after that, there's a little bit, like once the patient kind of completes that, then the doctor can be notified, so to speak, that the patient is ready to see them now. And then other types of like more of a follow-up chatbot as well on the back end that checks in with the patient after the appointment. So based on maybe symptoms that they were having, seeing if they were still having these symptoms, or if there's anything else that they wanted to tell their doctor. That's possible too with, that's kind of like the flip side of this bot situation that we're showing here.
All right, thank you very much, very clear. We ran out of time, but one last question. Can you answer the trivia question?
You can, it's 20 seconds. Yeah.
All right, great. All right,
Yeah.
thank you very much for your presentation and the video, and hope you enjoy the rest of DevDays.
Thank you.
Thank you.